We know if the p of x equal to k represents a probability mass function, we have the equation that k, the sum of p x equal to k is equal to 1, and that is p of x equal to k is equal to b times k times p to the power k minus 1 equal to 1. And this term is equal to b times 1 times p to the power 1 minus 1 plus 2p times p plus 3 times p squared plus dot 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 equal to 1. And we set this term is equal to Sn. Sn is equal to 1 plus 2 times p plus 3 times p3 2 square plus dot 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 is equal to 1 over b. And this term is equal to we can find by times p to the left hand side. That's the right hand side equal to p plus 2p squared plus 3p cubed plus dot dot dot. We use this equation minus this equation. We have 1 minus p times Sn equal to 1 plus p plus p squared plus dot dot dot. That is equal to 1 minus p to the power n over 1 minus p. When n approaching the positive infinity, this term equal to 1 over 1 minus p. So we have Sn equal to 1 minus p squared under 1, and then this term equal to Sn equal to 1 over b. So we have b equal to 1 minus p squared. And problem B is to find the expected value of x. According to the definition, this is equal to k equal to 1 to the positive infinity. The sum of k times p times p of x equal to k, and this term equal to the sum of b times k squared p to the power k minus 1. And we have the sum of p to the power k equal to k from 1 to the n, 1 minus p to the power n over 1 minus p, when n is approaching the positive infinity, p is larger than 0, less than 1, so p to the power n is equal to, is approaching 0. So this term is equal to 1 minus p under 1. When we derivative the both sides of this equation, we have the sum of k times p to the power k minus 1 equal to 1 minus p squared under minus 1 is equal to 1 over 1 minus p squared. And the equation is p to the power k minus 1 equal to 1 minus p squared under 1. And we times p to the both sides. The left hand side equal to the sum of k times p to the power k equal to p over 1 minus p squared. And we derivative the both sides again. We have the sum of k squared times p to the power k minus 1 equal to 1 minus p to the power 4 under 1 minus p squared minus p times minus 1 times 1 minus p equal to 1 minus p cubed under 1 minus p and plus p and minus p squared. No, plus p is equal to 1 over 1 minus p squared. Oh no, there's wrong. This should be minus 2, and this is plus 2p, and the denominator is 1 plus p. And that is the sum of k times p to the power k minus 1 equal to 1 over 1 minus p squared. And we times p to the both sides of this equation. We have the sum of k times p to the power k equal to p over 1 minus p squared. And we derivative the both sides of this equation again. We have the sum of k squared times p to the power k minus 1 equal to 1 minus p 4 to the power 4, and 1 minus p squared minus 2 1 minus p times 1 minus p, and equal to 1 minus p plus 2 there have a p. Here have a p. 2p over 1 minus p cube and equal to 1 minus p cube under 1 plus p. And now we need to find this term. So here we have this term. That's the need to times b, and this term equal to, after times b, equal to sum of b times k squared times p to the power k minus 1. And this is equal to 1 plus p over 1 minus p cubed times b. This is equal to the b. B is equal to 1 minus p squared. So this term should be 1 plus p over 1 minus p. The problem C need we to find the expected value of x squared. And according to the definition of expected value, we have the sum of k from 1 to the positive infinity, k squared times p of x equal to k, and it's equal to b times k cubed p to the power k minus 1. From problem B, we already have the sum of k squared times p to the power k minus 1 equal to 1 plus p over 1 minus p cubed. So now we need to times p to the both sides one more time, and then derivative of the both sides again. When we times p, the left hand side is equal to the sum of k squared times p to the power k. The right hand side is equal to p plus p squared over 1 minus p cubed. And the derivative of both sides is equal to k cubed times p to the power k minus 1 is equal to 1 minus p to the power 6 under 1 minus 2 times p 1 minus p cubed minus p plus p squared times minus 3 1 minus p squared. This is 1 minus p squared, and this is equal to 1 plus 2 times p minus p minus plus 3 p plus p squared over 1 minus p to the power 4, and equal to 1 plus p minus 2p squared plus 3p plus 3p squared over 1 minus p 4 to to the power 4 and equal to p square plus 4p plus 1 over 1 minus p to the power 4. This is equal to the sum of k cubed times p to the power k minus 1. And we need to find this term. That is this term times b is equal to the sum of b times k cubed times p to the power k minus 1 is equal to this term times b. B is equal to 1 minus p squared. So this is p squared plus 4p plus 1 over 1 minus p squared. So the expected value of x squared is equal to p squared plus 4p plus 1 over 1 minus p squared. The problem D is need way to find the expected value of x squared minus the square of expected value x. And this is equal to p squared plus 4p plus 1 over 1 minus p squared. And this term is equal to 1 plus p and 1 minus over 1 minus p squared. And this is equal to 2p over 1 minus p squared. The problem E is we know p is equal to 1 over 3. So now we have p of x equal to k is equal to 1 minus p squared times k times p to the power k minus 1. K is equal to 1, 2, is equal to 4 over 9 times k times 1 over 3 to the power k minus 1. K equal to 1, 2, 3, dot, dot, dot. And we need to find the conditional probability mass function. That is p of x equal to k given x larger than or equal to 2 or less than and less than or equal to 5. According to the conditional probabilities property, we have this term is equal to p of x equal to k and x is between 2 and 5 over p of x between 2 and 5. And this term, if k is between 2 and 5, this term is equal to this 4 over 9 times k times 1 over 3k to the power k minus 1. And the probability of x equal to k given x between 2 and 5 is equal equal to 4/9 times k times 1/3 k to the power k minus 1 over this term is equal to p of x equal to 2 plus p of x equal to 3 plus p of x equal to 4 plus p of x equal to 5 and equal to equal to 4/9 times k times 1/3 to the power k minus 1 over 1 minus p squared times 2p plus 3p squared times 4p cubed times 5p to the power 4. We plug p equal to 1/3 in this. We have the right hand side equal to 4/9 times k 4/9 times k times 1/3 to the power k minus 1 over 392 over 729 and equal to 81 over 98 times k times 1/3 to the power k minus 1. So the conditional probability mass function of p of x equal to k given x larger than or equal to 2 or less than or equal to 5 is equal to 81 over 98 times k times 1/3 to the power k minus 1 when k is larger than 2 or equal to 2 or less than or equal to 5 and 0 else